Hi there. So in this video series, as discussed, we're going to be going through the 4D rotary toolpath operations. So first things first, let's get our model. So we're going to import this twist model. Both the model and this cell will be available for download at the end of this, of course. Now, first thing we want to do is we want to check the size and position and placement of the model, as usual. So we go to Properties, and we can see that it's pretty small, so I'm going to increase this by a factor of 5, should do it. So we go to Spatial Transformations, Scale, 5, and Apply. We locate the 0, middle, min, as we normally do. And we move it up by 100 millimeters in Z, and then click Apply. So now that we've done that, we can take a bit of a closer look at this. And while it's a very dark grey, apologies for that, I chose the wrong colour when designing this in CAD, we can see that it's a fluted column that's got a twist going down the length of it. So that should make for a fairly interesting shape to machine using rotary toolpath operations. So we go to the machining area now, and the first thing that we're going to do is we are going to set this to be sat on the rotary positioner. So that's now where we want it to be. And we are going to take a look at the operations that are available to us. So I'm going to click on Add Operation instead of the drop down arrow there. And I'm going to click on 4D Rotary, and we'll take a very quick look at these. So the rotary waterline operation is one that's better suited for where there is a lot of verticality in the model relative to the axial orientation. That's a bit of a statement to unpack, I apologise. So if we look at the example image here, we can see that if we were to look at the centre of the axis as being 0 in height, there's quite a bit going on with the shape moving away from that. Okay, so that's what I mean by this. So this will treat the radial axis in exactly the same way that a roughing waterline in a 3D space would do. So it will machine away the dominant chunk of the area, and then if you're using the cleanup cycle as well, it'll bring that into a much smaller, more refined cut. But obviously wrapped around the central axis instead of laid out flat across a panel. That's not an entirely appropriate toolpath for what we're working with at the moment, though. This is better suited to large-scale screw cutting, that kind of thing, and you know, the instance of this image, it's a large-scale Archimedean screw. So next, we're going to take a look at rotary roughing, which is a very simple operation. It's very akin to how fourth axis operations on a mill work. The same with the rotary finishing. So the piece is rotated, the milling cutter is pushed in relative to the axis according to how far in it needs to go. It's about as complicated as it gets. Morph 4D, 4D surfacing, and to a lesser extent 4D contouring are actually fairly closely related. Morph 4D is basically an expansion of what 4D contouring does. 4D contouring, as the name suggests, is how one would define traversing a contour on a 4D rotary surface like this, so a cylindrical surface that's making use of a fourth axis. Morph is the process of using 2 constraint lines instead of 1 to be able to define machining a single surface between them generally. 4D surfacing takes that same process and then expands on it further by giving you more surfacing and machining options further from that. And we will be taking a look at 4D surfacing a little bit later on, because it's actually quite an interesting process. But for now, we're going to start out with rotary roughing. So let's jump on this and we'll create a rotary roughing operation. And there's a few things that we need to do before we can actually start prepping this for machining. The first is we're going to go back to the root operation here, and we are going to set the workpiece, because we haven't defined that at the moment, and it defaults to a cube, which isn't quite what we're after. So I'm going to click on Primitive, We'll go with cylinder because since it's cylindrical mass, why not? I'm going to turn off same stock because I don't really want to mess around with stuff at the top and the bottom of the axial range because it's not relevant to what we're doing here and now. And I'm going to set the outer radial. I'm just going to move this over so you can see what I'm doing. I'm going to set that to 15 and then I'm going to click on add. And we can see now that we've got a cylinder that's 15 mil thicker in radius all the way around. So we close that now. That's defined. That's all we need from here. Now that we've done that, we need to set up the robot. The first thing we're going to do is we're going to enable axis E3 and axis E2. E3 is the linear rail and E2 is this turntable plate here. And we are now going to set the tool orientation and we're also going to set the rotary table vector. So for the tool orientation, might as well go with front, it works. And for the rotary table vector, I am going to set it to go along this axis here. At the moment, it defaults to going vertically down, which is not really what we want. We want it to correspond to the x-axis. So I'm going to go with positive x, and we can see that this blue arrow here, which conveniently goes orange as soon as I highlight it, is now oriented in to indicate the correct direction that we're going to bring the machine tool in from. So, beyond that, I'm going to increase the length of the machine tool because that one's quite stubby and it's not really helpful for our illustration purposes. So we're going to go to Tool and we are going to tell it that the length is now 250 millimeters, which might seem a little extreme to some, but for those of us who've worked in foam and prop making and the likes, that's actually a fairly small tool as it goes. They could get significantly bigger than that. And also it makes it easy to see what's going on in these videos. So I'm going to click on Apply Changes. Now the next thing that we should be paying attention to is the fact that for some reason the rotary axis is being described as being around the x-axis instead of around the z-axis, which is what we want. So to change this, we go to Strategy and we choose Rotary Axis and we set that to WCS-Z. Now you can see that that cylinder that describes it is much more closely correspondent to the actual shape that we're working on. There's a couple of other bits in here that are quite useful to look at as well. The main one is trajectory form. That allows us to define the manner in which the toolpath is constructed. And there are three options here. So if we click on the drop down menu here, we can see that we've got linear, which will be a linear path along the axis of rotation. We've got a circular path, which will be across or around the axis of rotation, depending upon how you describe it. And we've got a spiral path, which goes continuously along the axis of rotation in a helical spiral. That's what I'm going to choose here because it means that we can capitalize on having an unconstrained turntable. If you have a turntable which is limited to a fixed range, then you'll want to look at either linear or circular. Also, as a subset of this, there is another bit of functionality in here that's quite useful, and that would be angular domain. So in this case, we're going with the full circle, which is to describe the entire surround of this, but you can actually define angular ranges. So in this case, we've got 0 to 90 degrees here. And as we can see, this has now described a sector of a quarter of the circle. We can change these to whatever we want them to be. By clicking on this arrow here, we can now set the start and finish angle accordingly. So if I were to grab this one and bring it round, we can see that the finish angle increases. If I were to grab this side and bring it round, the start angle increases, and vice versa, of course. However, that's useful, but not useful to us right now. So I'm going to set this instead to full circle, and I'm going to change the trajectory form to spiral, and I am going to now go to parameters, and I'm going to set the stock settings, so I've got a little bit of an offset there. I'm going to set radial stock to 2 millimeters, going to set the tolerance to about 0.5 millimeter, so it's a little bit faster to calculate. And I'm going to click Generate Toolpath. And we should see we've got a nice and quick toolpath generated there as described by this green line. Now, if we need to, we can define which end of the shape that it comes from as well. If we go back into strategy, we can see here that the axial direction is described as forward. Were we to set this to backwards, it would mean that it comes in from the top and starts moving down instead of coming in from the bottom and moving up. That's all. The last thing that I'm going to define, just for the sake of being able to set it as an inherited property, is I'm going to set the links and leads to avoid collisions. This is just something that I do as standard practice. It's not 100% essential, and obviously if you're at the point of manipulating your own links and leads and your own feed-in rates and everything, you needn't worry about this. But to try and keep my life a bit simpler, I tend to do it as a matter of course. So I'm now going to regenerate this toolpath. It should only take a second or so to generate. And with that, we've now got ourselves a nice workable roughing pass. So we'll very quickly run through this as a simulation just so we can see what we get. I'm going to pan out a little bit here and I'm going to click on run. So we can see the robot coming into play now. And once it engages, I'll speed it up a little bit because we don't want to watch the whole thing at that speed. And here we go. So that will now cut up the entire length of the shape quite nicely, and it will then pull away. With that, we've now defined our first roughing path. Okay, in the next video, we're going to go through the rotary finishing toolpath, and there will be subsequent videos after that. So we'll see you then. Take care.